Good morning, and it looks like we're live again. Gonna send out the tweet that I forgot to send out yesterday morning. Turns out it is pretty easy to just be tired in the morning and forget to do some of the tasks that were set the night before. But at least I remembered to tweet out last night. I am trying a slightly different configuration of OBS today. You'll notice that my webcam is over on the left side this time, and I'm hoping to have the documentation high enough that it's readable. If there is a change that you think would be beneficial to viewing this stream, or would help you in looking at something and understanding, please leave a comment, let me know. I would be happy to sort of experiment with a lot of these different looks and feels until we get one that just works out really well. I'm also open to making the webcam smaller, changing panes, trying out all sorts of crazy random things. All right, I do not want that to be live the entire time. Looks like mic is working. Okay, so I think we're good. Let's continue on where we were at with Rust. So going through this book here, we're at the that's kind of annoying. We're at the comparing the guess to the secret number section. Also, so my code told me, hey, you're missing some tools, and so I clicked on that, and then it just began installing and compiling a bunch of stuff from Cargo. So I'm going to leave this running here in the in sort of the terminal window. Hopefully it will do some really cool things for us. But as far as I can tell, it's still running, and hopefully it won't take up too much CPU to compile and install. Okay, so now that we have user input and a random number, we can compare them. That step is shown listing 24. So in our main file, we have our external crate rand. Looks like we have a new use. So from the standard library, comp ordering, compare ordering. So we're basically extracting out this function, and it's a capital O. I'm wondering if that's a probably installing Clippy, RLS, and Format. They are amazing tools. Okay, awesome. Thanks for letting me know, Danny, and also welcome to the stream. Good morning. Okay, so this is probably for ordering something. Interesting. I guess they're putting it here so that it's right next to stand. So I guess the compare library, ordering. Okay, so I was doing this to make this a little bit to understand that. That's why it's different. Okay, so in our function main, we have our guess the number. Please enter your guess. We're getting the secret number. We're not printing this out at that point in time. We're putting it down here. Please input your guess. So let the mutation guess variable equals string new. So there we initialize guess to be a new string. And here's where we are getting that. We have our error in case things go horribly wrong. You guessed blah. And then we have this match. So guessed.compare. Oh, interesting. Okay. There's nothing that we're doing add them in here. So is .compare, is that just a method that's off of every single string? And then ordering here is a way to compare two strings and determine if one is greater than another. That's what it looks like. Okay, so match seems to be a keyword here. Guess dot compare. They're going to pass in a, looks like we're going to pass in a reference to our secret number. And then inside of that, this is where we're going to do, hey, if our ordering is less, and it looks like arrows. We'll figure out what those are. My immediate thought is like a fat arrow. Is this run this function in case if this is true? Or it takes a callback function? I don't know. So many questions. So ordering less print line bang too small. And then we'll do greater and equal. So ordering greater so greater too big. Ordering equal line. You got it. So we'll save that. Let's try running this. I guess we can't easily do that. Here, you can go to terminal. I need to go to chapter 2. See the guessing game. All right, so I can do cargo run. Aborting to treat 2 previous found errors. Okay, well, since that's really small, I am instead going to use the big terminal for that. So chapter 2, guessing game, cargo run. All right, what happened here? Expected one of comma, period, question mark, close bracket, or an operator found semicolon, source main RS line 22. Interesting. Let's take a look at their code again. Oh, these are not semicolons, they're commas. Is this some kind? Oh, that's really interesting. I was not expecting that. So are they commas because this is some kind of dictionary or list? That is very interesting how it takes. Oh man, okay. I can't wait to read the explanation for this and see what that is saying. Okay, so let's try this again. Cargo run. Cargo run. All right, what else? What else is wrong with you? Expected function found macro print line. Did I forget the bang? I forgot the bang on all of these. Save. Cargo run. Okay, we're getting down there. Mismatch types. Guess our secret number expected a structure sort of standard string found integral variable. Expected type entering string found type integer. Okay, that's interesting. Let's take a look at take a look at our code here. So we're just getting secret number. Well, yeah, this would be an integer. And so it's compare secret number expected a string because the guess is a string. That's my guess. It must be. So are there any other? Oh, yep. Ah, they're doing that thing in tutorials where they have you get an error on purpose and then later on say, oh, look, we got an error. Let's read what that is. And here I am trying to like actually debug this, but they're leading us down the wrong path because, I mean, in almost all languages, when you get some kind of input from the command line, it's going to come in as a string. And we were in fact seeing that when it came in, when it comes in right here, let our guess, it not only is going to come in as a string, it's going to come in with the trailing new line character, which potentially will, I don't know how that's going to affect this, but it does make it very interesting. I'm wondering if we're going to convert the number, secret number, to a string or convert guess to a number. All right, let's continue reading and see what we can see. Okay, so we have another use. We're bringing standard compare ordering into scope from the standard library. Ordering is another enumerator like result, but the variants for ordering are less, greater, and equal. Oh, that's all that they are. These are the three outcomes that are possible when you compare two values. Then we add 5 new lines at the bottom that use the ordering type. The compare method compares two values and can be called on anything that can be compared. It takes a reference to whatever you want to compare with. Here it's comparing the guess to secret number. Compare returns a variant of the ordering enum, so that's why compare returns a variant of the ordering enum. We brought into scope with the use statement. We use a match expression to decide what to do based on each variant of ordering was returned from the call to compare with the values in guess and secret number. So we tell it, hey, we're going to do this match thing. So I'm going to give you a bunch of these commands which take callback functions, which will do this if this is triggered. So it's like, hey, order. We use the ordering public method or static method. Hey, if guess compared to the memory location of secret number is less, I guess secret number is less than guess, then run this function. Okay, and it looks like it will only ever be able to run one of these functions, so that's why it works. Or maybe not. Maybe it can be greater or equal to, greater and equal to, in which case both of these would be called. That'll be interesting to sort of play around with once I get finished with this. Okay, so a match expression is made up of arms. An arm consists of a pattern and a code that should be run if the value given to the beginning of the match expression fits that arm's pattern. Okay, I don't know what it means by arms. That's a really weird word to use. A Rust takes the value given to match and looks through each arm's pattern in turn. The match construct and patterns are powerful features in Rust that let you express a variety of situations your code might encounter and helps ensure that you handle them all. These feature, okay. Oh wait, these are the arms. Rust takes the value given to match and looks through each arms pattern in turn. So starting here and moving down. So all of these will be expressions. No, it says patterns. It'll be a pattern, which is different than an expression. So if this ends up equaling, is this sort of like a switch statement, but with callback functions instead? I'm sort of getting that vibe a little bit. These features will be covered in detail in 6 and 18. Let's walk through an example of what would happen with the match expression used here. Say that the user has guessed 50 and the randomly generated secret number this time is 38. So we'll use this here since we lost the code. So we end up getting, the guess is 50, random number is 38. When the code compares 50 to 38, and a random generated secret number this time is 38, the compare method will return ordering greater. So this returns ordering greater because 50 is greater than 38. Ordering greater is the value that the match expression gets. So it is sort of like a switch statement. This will return and is looking for pretty much the exact same thing down here. Whichever ones it is, gets executed. The next arms pattern, let's see. What it doesn't say is, does this code even try to execute at all? Because it found greater, does it mean that it's done and it just leaves? Or does this also get checked? However, the code in listing 2.4 won't compile yet. Let's try it. Yes, we get this compare integer to number problem. The core of the error states that there are mismatched types. Rust has a strong static type system, however, it also has type inference. When we wrote let guess equals string new, Rust was able to infer that guess should be a string. And didn't make us write the type. The secret number, on the other hand, is a number type. A few number types can have a value between 1 and 100. So I32, a 32-bit number, U32, an unsigned 32-bit number, I64. Rust defaults to an I32, which is the type of secret number, unless we add type information elsewhere that would cause Rust to infer a different numerical type. Okay, it won't compare a string and a number type. Ultimately, we'll want to convert the string, so that would be our guess, into a real number type so we can compare it to the guess numerically. We can do that by adding the following 2 lines to the main body function. Here's our guess. We're just reading the line. Okay, so let guess colon U32. Interesting. My guess is the only way we're able to do this is because of the mutation on guess, and otherwise we would just create a new variable, right? I mean, that's my thought on this. So we're going let guess type U32. So I guess that there's no like int or U32 guess, because then that would just make the let. We wouldn't need that. So let guess type of U32 equals guess dot, ooh, trim. Why are they having us trim? Dot parse dot expect. Oh, interesting. Okay. My guess is they need this for that new line, and they're not telling us. Maybe they will. I'm looking to see where the trim is. We bind guess to the expression guess and trim. The trim method on a string instance will eliminate any white space at the beginning and end. Aha! So they finally mention it. If the user types 5 and presses enter, guess looks like this. 5, new line. The new line represents new line, the enter key. The trim method eliminates new line, resulting in just 5. Okay, so I could have just done, I could have trimmed it off of here, but let's, right here, what we want to do after we've gotten in the string, we want to now do this converting. So we'll say let, I also want to come back to out the output. It's still installing this. So it's just the same exact one again, and we're converting it to an unsigned 32-bit integer equals guess. We're going to trim it, and then we're going to parse it. Then we're going to have our expect. And if this is the where it passes, it returns the enumerator, which then has expect and like okay on it. So expect is when things go horribly wrong, and we're going to print out please type a number, and then it's going to crash. All right, let's save this and try running this again. Cargo run. Aha, here we go. Guess the number, enter your guess. We'll do 50. You guessed 50. The secret number is 44. Too big. Perfect. So that seems to run. If I want to try it again, guess really small. Too small. All right, that seems good. We create a variable named guess. But wait, doesn't that program already have a variable named guess? It does, but Rust allows us to shadow the previous value of guess with a new one. This feature is often used in similar situations in which you want to convert a value from one type to another type. Shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables. Well, okay, but is that because we have mute here? If I remove this and we run this again, let's see if I can put this, yeah, over there in the left. Cargo run. Cannot borrow immutable local variable guess as mutable. Oh, hold on. It's because this is also. Can I do that? Types differ in mutability. Expected type mute string. Oh, it's because I'm creating an empty string here. I need it to be mutable in order to put it in there. So that's the reason. It's not any crazy like this thing. So this is allowing me to essentially, this is how I can like reinitialize guess to be whatever I want it to be. All right. Where were we? Chapter 3 covers shadowing in more detail. We bind guess to the expression guess.trim.parse. The guess in the expression refers to the original guess that was a string with the input in it. The trim method on a string instance will eliminate any white space at the beginning and end. Yep, this is where we're going to remove that the /n, the new line character. The parse method on strings parses a string into some kind of number. Because this method can parse a variety of number types, we need to tell Rust the exact number type we want by using, okay, so it's going to figure out, by us telling the type here, it figures out what type of number to put it in here. Okay. The colon after guess tells Rust we'll annotate the variable's type. So we'll tell it specifically what type we want it to be. Rust has a few built-in number types. The U32 seen here is an unsigned 32-bit integer. All right, chapter 3, they'll tell us about the other number types. Also interesting, additionally, the U32 annotation in this example program and the comparison with secret number means that Rust will infer that secret number should be a U32 as well. I guess that I could also do this, right? And be extremely explicit about it. Yeah. So if I do this, then it doesn't have to figure out, and I've just told it what to do. And if I do, hey, unsigned 64-digit number, I'm probably going to get a compiler error, aren't I? Yeah, mismatch type, found U64, expected U32. So it's probably going to be one of those things where, hey, everything will be fine with it just figuring it out on its own until suddenly it's not. Then I need to go in and like change it all. Tell it what to be. The call to parse could easily cause an error if, for example, the string contained a thumbs up symbol and a print. Oh, there would be no way to convert that to a number. Because it might fail, the parse method returns a result type, much like the read line. Right, which is why we're able to use that .expect. If parse returns an error, result variant, because it couldn't create a number from the string, the expect call will crash the game and print the message we give it. If parse can successfully convert the string to a number, it will return an OK variant of result, and expect will return the number we want from the OK value. All right, so we run the program now. We've already done that. It works. Nice, even though spaces were added. Oh, right, so we could add spaces before and after the guess, and that's okay because of trim. And then, of course, we need to loop this because we want it to actually run. All right, this is taking forever to compile. The loop keyword gives us an infinite loop. Wait, really? Hey, Dinesh, welcome to the stream. Thanks for the stream. Well, thank you for stopping by. I wanted to do something back with streaming again, and learning Rust is a fun way to wake up in the mornings. So I figured I'd combine the two. Okay, so the loop keyword gives us an infinite loop, and add that now to give users more chances at guessing the number. So we don't need to bring this in or anything. Looks like we just use loop and give it a... Okay. So we're just gonna give it a like a body here. How do we break out? Currently we don't. I wonder if it's the break keyword like most other languages. But okay, so the idea is that please enter your guess. We want this. Well, okay. We want to create our secret number only once. Enter your guess needs to happen every single time we get. So I'm wondering if this is going, because here we're going to have our loop block, right? I'm wondering if this guess is going to be scoped specifically to that block and it's going to be destroyed and recreated again. That would be interesting. Hopefully it does. Okay, so then we're going to get our guess. Let guess equals U32. Then we have this. And then we have match. Then we have our match compare. Okay. So we're going to want our loop right here. So it's just loop, open bracket, close bracket, tab that in. But this will be an infinite loop, won't it? Cargo run. So please enter your guess. 50. Okay, secret number is 60. So if I then do like 61, too big, 60. You got it, but it doesn't end. Obviously, we don't have an end here. Now, what I'm wondering, and before I even look at this, I just want to try this. If I, instead of like having print line, if I have I had another idea too. Okay, so if I have this, I want to say print line, and then immediately afterwards, I want to say, let's try break. Turn purple, that means it's a keyword. All right, let's cargo run again. Ooh, please enter your guess. 50, number 63. Let's do 65. We're too high. 63. Aha, you got it, and it broke out. So what I like is that this was fairly intuitive for me to add in, okay, we're going to create a block here, and then all the code inside of this block is going to be executed as soon as we do this. And already immediately I'm going to think, okay, well, what if I create a new function that then like does these, and I can call these functions that work. I kind of like that idea. Let's go back and look at what we're supposed to do. As you can see, we moved everything into a loop from the guess input prompt onward. Be sure to indent those lines for another 4 spaces each. And run the program again. Notice that there is a new problem because the program is doing exactly what we told it to do. Ask for another guess forever. The user could always halt the program with Control-C, but there's another way to escape. Comparing the guess to secret number, if the users enter a non-number answer, the program will crash. Well, okay. Yes, you can put a non-number in and crash it yourself. Typing quit actually quits the game. Haha. Okay, quitting after a correct guess. Let's program the game to quit while adding the break. And yeah, they did exactly what I did here. They created a block in ordering. They did their print line and then a break. And that was it. By adding a break line after you win, the program will exit the loop when the user guesses the secret number correctly. Exiting the loop also means exiting the program because the loop is the last part of main. To further refine the game's behavior, rather than crashing the system when the user inputs a non-number, let's make the game ignore a non-number so the user can continue guessing. We can do that by altering the line where guess is converted from a string to U32. Ooh, okay. So when we have this, let guess, trim parse, yeah. Oh, interesting. We're going to use a match here. Okay, and then brackets, and then we say, hey, right, because this is going to return an enumerator that has the okay, it has the error, and it has, is it just those two? If we're okay, it passes in what this was going to be, and then we just return the number. Otherwise, we don't do anything at all. Interesting. Is this because you're taking in something, but you don't want to show that you're taking in? The underscore is a catch-all value. Huh. We're saying we want to match all error values no matter what information they have inside them, so the program will execute the second arm's code. Oh. Is this... So I would think that this is taking in, like okay is passing into us the number. The expression will turn the num value that parse produced and put inside the okay value. Yeah. All right, so that's sort of making sense. It's kind of like a try catch almost. So we have our let guess, and we want to match here, and then we're going to have an open bracket and a closed bracket. But now instead of expect, now we're going to have our arms, as they call them. Okay, so we're going to have okay. So if it's okay, they're going to pass it a number, and then we're just going to return that number, comma, because it's a new thing. If we get an error, we want to just take in whatever the heck it is, but we don't care about the error at all. We just want to continue the loop. And continue in most languages means, okay, stop this one, start over again. All right, switching from expect call to a match expression is how you generally move from crash on error to actually handling the error. Remember that parse returns a result type, and result is an enum that has the variant error or okay. That's all. We're using the match expression here like we did with the ordering result of the compare method, which is down here. If parse is able to successfully turn the string into a number, it will return an okay value that contains the resulting number. Let's see. The okay value will match the first arms pattern, and the match expression will just return the num value that parse produced and put inside the okay value. Right, because my guess is whatever is returned from here is sort of like returned all the way into guess. Because I could do something really silly and return 5. If I do this, no matter what I put in, I'm guessing 5, aren't I? Ooh, error. Hold on. Let's go check out what it is. Where is that? Expected one of dot semicolon question mark or an operator found print line 26. Oh, is this supposed to be... No, it doesn't need to have a semicolon there. At least I don't think it does. Ooh, they have it be a semicolon. All right. Oh, is it because, so this is a match. This is just a full match, and this is an expression that matches inside. Is that the reason why there's a semicolon there? Probably. Type annotations needed. Cannot infer type for any. Interesting. Okay. So it takes in this type, but that one has, because it's any type. Okay, hold on. Can I do something like U32? No, it doesn't like that either. This is often what I'm doing when I'm learning new things is I'll diverge from the book and just sort of like try random little stuff so that I can understand it here. Okay. It isn't any type, it's the type of guess. But the type of guess should be a unsigned 32-bit integer, right? So why was it telling me that it was any type? That was weird. So it of course didn't like me putting in colonets. That's not how I tell what type it is. I mean, so it's expecting this U32 here. And then unreachable statement. Well, all these are all from this first one. I'm just, and maybe Danny, you can help out with this. Right now, is this like a function call where I'm taking in num? Like, I guess I need to, I want to know more about these callback functions. Is whatever is coming in here being returned, and that's returned out here? The return just needs to be U32. You decide how to get there. Okay, so when I did like 5 like that didn't work. But if I have a full block and I say, let no, that is a destructure on the left. The right is the code block when the left is true. Oh, interesting. Okay. So this isn't a function, this is just code blocks, and we're destructuring without any symbols here. So it returns essentially an object. We have a num key in that object. We're extracting it here and making it. So this underscore is sort of like just whatever. It's anything, everything. But since we don't care about it, we just do that. And then we just, is this auto returning? I think this num is auto returning. If I do a block and do num here, is this going to not work anymore because it's not auto returning? That's my theory. Or it's going to be fine. Yeah, if you leave off, it just returns what you have there. But why is this working? I saved it. No semicolon is a return. Wait. Okay, that doesn't make any sense to me. I'm thinking, so then if I because I have a comma there, if you want to break it, you need. Oh, okay, so I put this in here, and then I can do like return num like that. So I could theoretically do let my num colon u32 equals 5. And then I want to return my num. Nope, that didn't work either. In Rust, if you don't terminate a line with a semicolon, it is an implicit return. Oh, interesting. If you don't terminate a line with a semicolon, it is an implicit return unless it's not supposed to end, in which case it continues. That sounds interesting. Mismatch types. Return my num. Oh, I needed a comma here, I think. All right, let's see what's going on here. Expected, open, close, parentheses. Hold on. Found U32. Okay, that's not what I would have expected to be the error. Do I want to have this, because right now I'm having this be string, and I'm pulling string. No, I'm not pulling string out of there. Is there like a U32? I would think it has to be a U32, not open close parentheses. That's what I was found U32. This is really weird error message. Unless I'm just reading this completely wrong, I would think it has to be U32, not. Yeah, like is my num U32. Okay, so is this really what I think that it is? Or do I just want to do that and then it will figure it out? It's probably the return. It might be returning from the function. Okay, so I want the implicit return then. Move the return in a semicolon on the line. So I do this, return this. Save. Type annotations needed. Cannot infer type for num now. Okay, so do I have to tell it colon U32? No, that's not how to type annotate. I'm just sort of guessing randomly now. Is it U32 like in C? Or many other languages? No, it is not. Okay, I'm not going to just guess randomly too long here. But that actually did make that error go away, so you were right. Replace the num with underscore. Oh, right, because it just sort of, it's like this error. Just whatever is in there, just go in it. And we don't care because we're we're setting this. So cargo run, type annotations required cannot resolve. String standard function error equals underscore let guess u32 equals match guess trim parse. Interesting. So we're just sort of like moving up as it's like, I have no idea what's going on. Well, the compiler doesn't know what's going on, so that's fine, right? So now here it's like, what was I supposed to be returning? This is interesting. Welcome to Rust, where everything is an error. Okay. So I guess this is gonna be my future with Rust, is figuring out all these weird errors and what's going on and why. I'll probably come out and like play around with this a little bit later, but for right now we're gonna put it back. But it's super interesting that I can't just statically say, hey, I'm returning 5, like here's your guess. That is fairly cool though. Rust is like, you can't parse and then drop the value. That's what it looks like. Like unless I like take the num in and print line it first. Cool number. If I do that, cannot infer type for underscore. Now, if it's destructuring, if I do underscore, can I do like underscore dot num to get it here? I feel like this is way, like I need to know a lot more about the language before I can do something like this, which is a very interesting, but I guess it's part of the fun of systems languages. That's what I remember learning about C is like, oh, it's so easy to get lost. Even though it is simple in the end, it's just, you have to understand what's really going on in order to do it properly. So with that, let's put this back. We're just going to auto return num here. And we're fine again. Okay, so let's come back to this. Having invalid input. To further refine the game's behavior rather than crashing the program when the user inputs a non-number, let's make the game ignore a non-number so we can continue guessing. So this is where we had this, hey, if there's an error, whatever this error is, we don't care. We don't really, I guess we're not doing any destructuring. We'll just continue. Switching from an expect call to a match expression is how you generally move from crash on error to actually handling that error. If parse is able to successfully turn the string into a number, it will turn an OK. Otherwise, it will turn this error. The OK value will match the first arms pattern, and the match expression will return the num value that parse produced and put inside the OK value. That number will end up right where we want it in the new guess variable that we're creating. If parse is not able to turn the string into a number, it will turn an error value that contains more information about the error. The error value does not match the OK num pattern. The underscore is a catch-all value. In this example, we're saying we want to match all error values, no matter what information they have inside them. So the program will execute the second arms code, continue, which means to go to the next iteration. Yes. Now everything works as expected. Awesome. With one tiny final tweak, we will finish the guessing game. Recall that the program is still printing out the secret number. That worked well for testing, but it ruins the game. Oh, well, yes. We can just remove this. You guessed, blah. In fact, oh yeah, I could remove this too. Let's delete that. And then we have our final code. And then we complete our guessing game. So we save this, and then we can run. So cargo run. Please enter our guess. 50. Too small, please enter your guess. So 75. Too big, 60. Too small, 65. Too small, 70. You got it. Okay, perfect. At this point, you built the guessing game. Congratulations. This project was a hands-on way to introduce you to many new Rust concepts. Let match methods, associated functions using external crates, and more. In the next few chapters, you'll learn about these concepts in more detail. Chapter 3 covers concepts that most programming languages have, such as variables, data types, and functions, and shows how to use them in Rust. Chapter 4 explores ownership, which is a Rust feature that is most different from other languages. Chapter 5 discusses structs and method syntax, and Chapter 6 endeavors to explain enums. Okay, I love how they tell all of these will do it. Chapter 6 will only attempt to do it. Good luck. Yes, woot indeed. All right, so it is almost 8 o'clock, which means the end of the stream. I do want to sort of think about what I want to do. Before I move on to chapter 3, I want to try creating, like redoing this guessing game, but with the opposite, where it will ask the human for a guess, and then the computer will use potentially the cut in half method while searching for it. So that will be sort of interesting to see if I can redo this while just using this documentation as my reference. So for right now, before I forget, I want to put this code up there. In the description of the stream, I did make sure that the link to this code is up on GitHub. So let's go ahead, add in our main changes. We have guessing game working. So we'll send that up and sync it with the server. These tools still have not compiled and installed, which is a little bit sad because I will be bringing my computer into work in less than half an hour when I leave for it. So hopefully that won't just fail the install. When I get there, I'll just open up my computer and let it run all day, and we'll see if we get it for tomorrow. We have whatever tools they are that really help out. Other things that I would really love to play around with is cleaning up this function. It should take around 5 minutes. Well, it's been a little bit long. Like most of these, like this is a lot of tools. And in the very beginning, all I was installing was Racer and Rust Sim. And it looks like it finished a lot of them. Finished a couple of them, but yeah, I know. And it was VS Code had this Rust tools installed. Click here to install them. So that's what I did. And it's doing a bunch of stuff. No idea. I'll probably need to reboot or figure something out. Is VS Code using Racer instead of RLS? No idea what that is or why that would be important. But the code should now be up on the server, so everything should be good. I'm thinking that last time it successfully uploaded the video. Hopefully it does the exact same thing. But with that, I am done warming up for the day, And tomorrow we'll be getting up early and warming up again, continuing on with sort of making our own game. And with that, I hope that you have a great day. And if you're watching the VOD, I hope that your day has been going great. And I'll see you tomorrow. And click.